I wish I had more desk space when I needed it.
Hey guys, I'm Anuj.
I'm Marcus. I'm Carlos.
I'm Pinqian.
And this is the expanding area desk for dorm room application, aka E.A.D.R.A. The primary purpose of E.A.D.R.A is to provide extra desk space in crammed up places like a dorm room whenever you need it.
The E.A.D.R.A is pulled out from the stow position. As it is pulled out, an expanding link with the spring enclosed pushes an input link down, and the coupler pulls the legs down into the fully deployed position.
This is our geometric design that matches our prototype. It is a 4-bar mechanism with the link 4 being the leg link and link 2 being pushed by the spring-driven link.
For the kinematic analysis, we started with the two positions that we knew we wanted to achieve. We knew that we wanted a slim profile in the collapsed position, and then we had a set height that we wanted to reach in the deployed position. Through graphical linkage synthesis, we found our ground points and the length of our links. Once we found those, we performed kinematic analysis to observe the angular position of link 4, the extending desk leg, versus link 2, the input link.
For the force analysis, we wanted to observe two things. We wanted to find the maximum reaction forces at the joints given a maximum force of 50 newtons from the spring-driven link. Furthermore, we also knew that with a transmission angle as low as 5 degrees between the coupler and the input link, friction in the joint connecting link 2 and ground would play a role. Here, T12 is a torque as a result of the frictional force multiplied by the radius of the pin. We set up our linear set of equations to go along with our free body diagrams and plug into Excel. We found that the joints experience relatively low forces and the pin's frictional torque is low enough to use standard bolting hardware in a full-scale version.
For our stress analysis, we solve for the minimum cross-sectional area for the legs and also the safety factor if the legs are solid 1x1 square inch. In our stress analysis, we assume that the load on the table is equally distributed on each leg, and the force is a point load on each leg. The bearing stress on the joint are insignificant compared to the buckling stress. Since the legs are slender, we use Euler's equation for calculating the minimum cross-sectional area with the properties of aluminum. The results for the minimum side length of the cross-section square of the legs is 6.43 mm. When comparing to our original 1x1 solid square inch cross-section, our safety factor was 15. Future improvement can be made by making the legs hollow.
Thank you guys for watching.